Okay, guys, let's look at this. What'd you guys get as an answer? 9 pi minus 32. That is correct. I'm going to go through it just to make sure we're all good. All right, guys. So first, you've got to remember your product rule. If I just want h prime of x, that's going to be g of x times f prime of x plus f of x times g prime of x, right? So if I'm looking for h prime of 4, it's that, but with 4's in instead. So g of 4 times f prime of 4 plus f of 4 times g prime of 4. And then you're literally just plugging in those values from the chart. So g of 4 was 3 pi. F prime of 4 is 3. F of 4 is negative 8. And g prime of 4 is 4. So 9 pi minus 32. Simple once you see it, okay? All right, any questions before we start our notes? Okay. 10-5, guys. That's where we are today. Guys, counting today, you only have 5 actual notes to take before the end of the year class. That's what we have. Because we have 2 left in Unit 10 and there's only 3 in Unit 11. So it's kind of crazy. All right, so 10-5, we're dealing with critical numbers. All right, you are given f of x equals x cubed minus 6x squared plus 15. We're going to use this function and walk through a bunch of different steps. All right, the first thing we are going to find is f prime of x. So what do you think, guys? What's f prime of x? 3x squared. Yep, minus 12x. Good. Okay, so just reviewing from last time. All right, what we're looking for next. When does f prime of x equal 0? So we're going to take that 3x squared minus 12x and set it equal to 0. So what do I have to do to solve that? Okay. What do you want to factor out?
3x.
I'd probably do 3x because it's going to make the rest of the factoring easier to see. Because then you'll have x. Actually, we don't have any more factoring. Sorry, guys. Later ones we do. We've got x minus 4 left. So what are the 2 x values for when our derivative is equal to 0. 0 and 4, okay. All right, so far nothing too tough. All right, I want you to graph f of x on a calculator. I'll graph it up here, so if you don't have your calculator, that's okay. This is not, like, you don't need a calculator throughout this unit. This is just for you to see what's happening on this one. All right, so our f of x was, so the f of x, not f prime of x, okay? X cubed minus 6x squared plus 15. So guys, I'm gonna make the y values on my window just a little bigger, so hopefully I can see everything. We'll try negative 20 to 20. Yeah, that would work. Give you a second, make sure everybody's got this on their calculator. If you're having troubles graphing, let me know. Make sure you're back to your function mode instead of polar mode. Okay, I'm gonna bring the calculator back up here in a sec. What we're doing with this, we want to find the relative max and relative min of f of x. Pull my calculator back up. Do you guys remember what relative max and mins are? No? Okay. So a relative max, it's a maximum, but it's not the highest point anywhere on the graph. So relative max is like the top of a hill. Do you see the top of a hill somewhere on your graph? Yeah. Are we okay with it? Looks like right there. Okay. So relative min, same idea. It's a minimum, but not the absolute lowest your graph ever goes. So it's like bottom of a valley. So are we okay with this as a minimum down here? Okay, you can actually find the coordinates with your calculator, and I'll show you how to do that. I'm guessing you didn't actually do this last year on your calculator. This one you know? Okay, you guys remember? So if you push second trace, it takes you into the calculate menu. I'm going to find the maximum first, which is number 4. It says left bound and a question mark. That just means be on the left side of the max, so left of the max. You don't have to be like just perfectly right next to it, just anywhere on the left side of it, okay? And I push enter, right bound. I just want to be somewhere past it on the right side, push enter. And then your calculator is saying, do you want me to guess for you? Yes, I would like you to guess, so I push enter again. Okay, I'm getting an x value of negative 1.938 e to the negative 6. What does that mean? Andrew? Approximately 0. Yeah, and look at the graph. Doesn't it look like that's an x value of 0? Yeah, your calculator is doing weird things, guessing for you. But it's really saying that this point up here is the point 0.015. Okay, I also want to calculate the minimum down here. So I'm going to repeat that process, second trace. Instead of maximum, though, I'm going to pick minimum, number 3. I want to be on the left side of it. So somewhere over here. I want to be on the right side of it. And I want it to guess. It's telling me the point 4, negative 17. And again, guys, this is not a calculator test. There's not going to be a section where you have to be able to calculate the max and min with your graphing calculator. It's just a quick review of how that works. Okay, so let's take this back to our notes. So I know the relative maximum was 15. Whoa. And that happened at x equals 0. And I know it was negative 17 at x equals 4. Anybody notice anything?
That's the coordinates we found where f5 equals 0.
Exactly, right? Don't I already have x equals 0 and x equals 4 up here, and now I just found them again? Okay? That's what happens. Where your derivative is 0 or undefined, you're going to have a maximum or a minimum on your original graph. So that's sort of what this leads us to. So that's kind of an exploration for you guys. So the relative max or min of f of x, so of the original function, will happen where f prime of x equals 0 or is undefined. So that's what we're going to be using the derivatives for today. We're going to be figuring out what's happening on the original graph based on where our derivative is equal to 0 or undefined. Anybody questions about that so far? This is where it starts to get a little bit tricky. You're going to visualize what's happening to an original graph based on the derivative, okay? So your brain will start to hurt just a little bit today, but it's not too bad. Okay, so let's try one. Let's find the critical numbers. And guys, the critical numbers are what we just, it's where your derivative is 0 or under. Okay, I'll label that on here. So these are the critical numbers. All right, so find the critical numbers, and without graphing, decide where g of x is increasing or decreasing and has extrema, meaning maxes and mins. All right, so I'm going to give you g of x equals x cubed minus 12x. And we will walk through all of this one together, okay? Extrema. Extrema. And what I mean by without graphing is without graphing this on a calculator. Like, you're welcome to make a sketch of it, but don't graph it on a calculator. All right, so critical numbers, which determine where our maxes and mins are, which helps us see where it's increasing and decreasing, all come from the derivative being 0. Okay, so the first thing we have to find is the derivative. So what is g prime of x? Good. 3x squared minus 12. All right, then we're setting that equal to 0. I'm going to go ahead and factor out the 3 when I do that. That 3 in front, does it matter? No, it's not going to give me any sort of solution for x, so I don't really need that there. The x squared minus 4, though, can I factor that again? Good. So x minus 2, x plus 2. So our critical numbers are x equals, what do you think? Yeah, I'm just going to write plus or minus 2. So we're here, right? 0 equals 3 times whatever. I could divide both sides by 3 and then it's essentially just gone, right? It doesn't have a variable with it, so it's not really doing a lot for us. Okay, so that was step 1. Find the critical numbers. Good job. Okay. We're going to figure out max and mins, like what those are giving us. To figure out if it's a maximum or a minimum, though, we need to know if the graph is increasing or decreasing. So let me just show you on this calculator one again. This up here is a maximum, right? That's because the graph was increasing and then changed to decreasing. Like, does that make sense in your brain? If you're increasing and then decreasing, that's creating a maximum. If it is decreasing and then switching over to increasing, that creates a minimum. Okay, that's what we're going to test with our number line. So I am going to make a little number line here. Whoa, not like that. The values I put on my number line are those critical numbers, so -2 and 2. Like before when we did number lines, just make sure you put them in order. Okay, this is just like number lines earlier in the year. What's really easy to test in a number line? 0. Okay, which section of the number line would 0 be in? The middle. Okay, I am plugging 0 into this G prime. Okay, I'm going to plug it in right here because that's the easiest place to plug it in. So 0 minus 2 would give me a negative number. 0 plus 2 would give me a positive number. So overall, what is that little section of the number line? Negative, which does mean decreasing. You were right. Okay, do you guys remember, if I don't want to actually plug in values for the rest of the number line, what can I do?
The exponent is odd, it's like every other one.
Okay. Yes. Multiplicity stuff. If it's odd, it alternates. What if it's even? Think if I graph y equals x squared with an even exponent. What happens at 0? Bounces, right? Okay. Oh, guys. Stuff has to live in your brain. There's no multiplicity with those factors. It's just x minus 2 and x plus 2. That means my number line will alternate. The only time it doesn't alternate is if you see like x minus 2 quantity squared and even multiplicity. Then you have to recognize what's happening. Without that, though, I know this will alternate. So plus, minus, plus. Are we okay with that? Okay. What this is telling me is what the original graph is doing. What do you think a positive section represents? Increasing and negative? Okay, so I'm going to draw a little graph. I'm not putting it on an XY grid, just the direction. So for this section of the number line on the left, I know it increases. And then at -2, it's going to switch to decreasing. At +2, it switches back to increasing. Does that little drawing make sense to you? Okay. Making that sketch makes it really easy to see. Is -2 a maximum or a minimum? Maximum. And what about +2? Minimum. Yes. Okay. So remember, this is sketch of g of x. I don't put the xy coordinate plane on there because I don't want to think about at all like where these things are really happening. Like I don't know what the y values are off the top of my head. I just want the shape so I can see increasing, decreasing, maximum, all that stuff. Okay, so what you have to tell me in your final answer is where is this graph increasing? Where is it decreasing? And then what is the relative max? And what is the relative min? So for increasing, guys, I think you're good. Like, we recognize it's this section over here and this section over here, right? Like, your brain understands that's going to help. To give me the interval, you're telling me over what x values is this increasing. So I know it's over here all the way to an x value of -2. Well, what's all the way over here? Negative infinity, so it's increasing from negative infinity to -2, and then from 2 to infinity, yes. So with that, you always use parentheses. So negative infinity to negative 2, and then again 2 to infinity. What would you tell me for decreasing? Negative 2 to 2. Good. And again, always parentheses when you're doing the increasing and decreasing, because at the point of negative 2 or 2, it's not doing either. It's changing direction, so just use parentheses. Okay, relative max. We know that happens at x equals negative 2. How do you think I'm going to find the y value, like what the maximum actually is? Plug it into the original, yes. So I need to plug negative 2 in way back up here. Use this guy. So negative 2 cubed minus 12 times negative 2. That's what you should be doing. And what do we get?
16.
Yeah, 16 when you plug in negative 2. And then the relative min, we know that happens at x equals positive 2. Again, plug it back into the original. Matthew, what'd you say?
16 and negative 16.
Yep, negative 16 for that one. That is the actual answer here. Okay, questions? Matthew first.
Can you also just figure out which x value is max and minimum by just plugging both in and whichever gives you the greater number?
So what if my graph does something, what if I have multiples? What if it's like that? So this number is bigger than this number. But is that a maximum? No, so you don't always know. Or what if your graph, is coming the other direction? You might not see everything that you need to see. Okay. Those are terrible drawings, but I think you get the idea. So, and I'm also going to ask where it's increasing and decreasing. So use the number line to help you just visualize all of that. Okay. Question? Same thing? Okay. Does that make sense? Why you got to think just a little more? Okay. All right. Let's try another one so we can repeat all of that, okay? All right. Same directions. I'm not going to write them all again. Should have called it A and B, but anyway, same directions. So your g of x this time is x to the 4th over 4 minus 2x squared. I want you doing all the same stuff. I want you finding the critical numbers. I want you making a number line, figuring out increasing, decreasing, relative max, relative min. Okay? And I want you to try it. Guys, I'll scroll back up and try to leave, I guess a lot of this isn't actually going to show up for you, but I'll try to leave some of that up there for you. So you don't have to flip back and forth quite as much. Did you guys get the equation? The derivative is actually nice on this. It looks like it might be ugly, but it's not. Promise. Yeah. It would just be x to the 3rd. Yeah. Yep. So yes, that's step 1. Find derivative. You're going to have 4 times 1/4. Right? You see it? Okay. All right, I'll scroll back up in case you need.
The one where we need to do the maximum in order for it to be correct. Or like the like where it's in
Maybe. As the degree gets higher, like we're up to x to the fourth now, you're going to have multiple max and mins. Or, you know, more than one of each, I'll say. Definitely work together on this, guys. How many critical numbers did you guys get? 3. What were they?
0, 2, and -2.
Perfect. Okay, you're off to a good start.
And then you get the next, it's like negative times positive times negative, which ends up being positive. And then since there's no negativity, you just so that's it. For the min, do you have to put both of them in and do the lower one?
No, they are both relative mins.
So there are just two?
Mm-hmm. Yep. Two relative mins. Okay. Okay. Check with each other again, make sure you've got it. I'll go through it too, just to make sure we're okay. All right, guys, when I go to test my number line, can I plug in 0? We always say 0 is the easiest to plug in. Can I plug in 0? No. If it is one of your critical numbers, you cannot use that as the thing you test. So I'm going to plug in 1 because that's also pretty easy to plug in. So 1 would give me a positive, and a negative. So overall, what is that section? Negative. Is there any reason this number line shouldn't alternate? Nope. So this is going to be positive, positive, negative. Okay, so that means your graph is going to decrease to -2, increase to 0, decrease to 2, increase afterwards. Kind of looks like a W. So if I'm writing out my intervals for increasing and decreasing, it is increasing from -2 to 0. You always read it left to right, okay? Read across your graph. And then again from 2 to infinity. It is decreasing from -infinity to -2. And then again from 0 to 2. Are we feeling okay about increasing and decreasing? That makes sense? Okay. Just take it from your number line or the graph, put it in the intervals. All right, I can see that I'm only going to have one relative max, and it's going to happen when x is 0. So remember, we go all the way back up to g of x and plug in 0. What do I get? 0. Okay, so your relative max is 0 at x equals 0. Do you guys see how I have two relative mins? Relative min just means somewhere on the graph that's a minimum. So you can have multiple relative mins. 4 maxes. It's fine. So I need to plug in both the 2 and the -2. Do I get the same answer? Yeah. What do I get? Yep. So you can say -4 at x equals both positive and -2. And there's your answer. All right, how do we do? Okay. Questions? Doing all right? It's kind of, I mean, it's a decent length process, but it is very procedural. You find the derivative. You set it equal to 0. You make your number line. You sketch your graph. You answer it. Okay? So just to recap, you find the derivative and set it equal to 0, and those critical numbers are where your original graph is going to have maxes and mins. When you're talking about the increase and decreasing, it's of the original graph. So this is what g of x looks like. Okay? You're not sketching the graph of g prime. All of this is g prime, but it's telling you about g of x. Okay? It's easy to get that mixed up. Okay. That's the end of notes, guys. It's just those examples. So you have a good chunk of time to work on MathSpace today. The MathSpace homework for today is a little bit longer than it usually is, so I wanted to make sure you had time to work on it, okay? So go ahead and start that for me.